So, good morning guys. Today we are going to discuss about one of the failure about the helicopter Sikorsky S-76. So it has crashed our helicopter. So here we are going to discuss about the 5 stages of design thinking framework. It will use us to understand how the helicopter can be designed as in a safe condition even though there is a failure. So let us begin with the discussion of all 5 stages. You all can propose the new way of helicopter without failure or maintenance, or the pilot how we can handle the helicopter during the failure case, right?
Okay, so we're going to link design thinking with Sikorsky S-76 aircraft clash. So first step is empathizing in design thinking. So what is design thinking? Is the method of approaching the problem correctly. So the first step lies is empathizing. Empathizing is something to understand the problem faced by the pilot and the aircraft and stuff. So basically S-76 is actually an helicopter that is completely different from a flight. The airplanes is completely different from a flight because vertical takeoff is available in helicopter as there is no available in flights because they need runway. So in helicopter the blades aren't fixed. Actually the main problem is the blades aren't fixed and they have the capability of pitching. So that will be the problem and the change in angle. So as you take S-76, we have to empathize the problem. So the problem of F-76 is when the engine gets failure or the gearbox malfunctions, what can the pilot can do? So what can the pilot do is they can do auto-rotating method. So that is the toughest and the hardest method the pilot can do. So how the way we can make it easier, we have to be on the people's shoe and we have to understand the stuff that how can it be done easier and to make it clear what are the extra steps can be taken and what allocation can be done and all. So that is the first step of design thinking and that is called empathize. So in S-76, Sikorsky S-76 helicopter, this step is the first scratch of design thinking.
What is the next stage?
My stage is defining what's the problem. So we have an engine failure. So we have a concept called autorotation. So if the rotation is enough, it means the propeller part will spin freely. So where the problems come is for simplicity we take as a car. So if we moving a car at high speed at 50 gear, suddenly we change the gear to neutral. So for that instant it will be a very tougher to control the speed and drag. The same problem for the helicopter also. During auto-rotation, it is in a free rotation. So it is difficult to control the RPM. So for a safe flight, we must control a specific RPM. So that's where the problem arises. For more also, if we take the other problems like during engine failure, we have to stable all the 3 conditions like pitch, roll. The 3 conditions should be static ready. So that's the problem we have.
Okay, the third stage is ideation. So what is ideation? Ideation is something brainstorming the things, okay? So after defining the problem, so once you empathize and you will define the exact problem is faced by the helicopter. So once you define the problem, you have to go for ideation. So ideation is something brainstorming the things. So you have to destigmatize the problem and be on the problem and we have to allocate things. So what can be done in order for when you take in Sikorsky S-76, what can be done for the maneuvering RPM depletion and also failure in engine and gearbox power. So when the gearbox malfunctions and the engine gets failure, as I said, the pilot uses auto-rotating method. So how can it be because the RPM gets lower, so there must be, because as it's helicopter there must be a vertical takeoff. So how can they solve the thing and how can you allocate the problem? So you can also use fully actuated rotor system and high inertial composite blades because as the blade pitches often and the angle changes because weather is not common for every place. So as you move place to place and also time to time the weather fluctuates and changes. So according to the weather, the blade should move and the angle should also be balancing the load. As you know, the wing connected to the load to balance the helicopter. So we can also change the stability augmentation system here and also high inertial composite blades.
So here one more point to include in the idea. This is articulated feathering blade. So here we are using composite blade. Instead of using metal blades, we are switching to composite blade. The weight of the blade will get reduced. If the weight of the blade get reduced means the inertia will get reduced. Once it gets failure means this composite blade is very light in weight. So during the free rotation or the free wheel condition, autorotation condition, it is easy to control by reducing of the weight. This is one thing. Second one is dynamically unstable condition. It is actually disengaging from the gearbox and it is free wheel rotate. So this time the vibration will get reduced and it is a composite blade and it will reduce the dynamic instability. That is one good idea of using composite blade. So let's move into the prototyping of testing.
So prototype with for Sikorsky S-76, we have test programs where the descent rate versus rotor RPM is tested by helicopter while the helicopter lands. So they take the RPM speeds in a different occasions and then they calculate it, and then pilot control inputs where the helicopter, how they observe how the helicopter reacts when the pilot gave the controls, and then response to turbulence where the helicopter is observed when the rough windy turbulence occurs in helicopter, and also change in blade angle of attack while the rotation. So they also check the spin while helicopter lands or is in air, and then they also stabilize the pitch, roll and yaw, where the pitch they check the nose up and down, and then in roll they check the tilt left and right, and then in yaw they check the turn left and right, and then during prototype and simulation the pilots are proposed to do the simulation because when the engine is out they can be aware what to do on that time, and then also they take a quick collector reduction while the rotor is due. And then the engineers monitor performance like vibration, pace lag, and then rotor inertia also. So while having theoretical testings and everything, we can do it in a practical way so that the crashes and outputs
failures can be reduced.
Yeah.
Excellent. This is an excellent prototyping way. Now we cannot do all the real-time prototype. We can collect the data, that is sample data and the existing data, and we can feed the existing data to the simulation models. We can give for individual blade pitch angles, angle of attacks, weather conditions, and the middle property, and operating condition, the various of RPM. These input data we can feed into the simulator. From the simulator, we can collect all the data from various performance, various conditions. With the data, we can sort out where the problem arises, where we can concentrate on the critical conditions that will help us to understand how actually helicopter performance in various conditions. For this Sikorsky S-76. What is the final stage?
So the final stage is test and run. So in the result, we get that for a safe auto-rotation, the pilot should lower its altitude differential. So, and more, the speed of the helicopter should be maintained about 60 to 80 knots. And also, there are many challenges like for a delay in the pilot response to the failure may cause the problem. So, what I feel is we can use AA. For engine generation, we have fast moving AA. So, when the failure occurs, we can use a AA to compensate that. So, the AA should be maybe more than a right, so it can reduce the problems of the leader. So another problem I feel that once the engine has been fired, the main rotor will be running on the field, but the tail rotor will be experiencing no running. So to compensate that, we have a three-way shaft to the tail rotor. So the anti-torque matter will be composite by that. So this is the test.
What is the information points for helicopter?
Sir, the main thing, first of all, I can say three conditions which are this is the main thing helicopter.
So by changing the blade parameters, blade materials, and simulation and testing the real time. These are the three things where you can improve the maintenance as well as the pilot centric, the human centric approach of understanding the real pain point of the pilot as well as the designer of helicopter that we are understanding here. And this helps us to understand how the aerodynamic phenomena changes the real-time operation of the helicopter. And you also get failures. The fail-safe condition helps us to land the helicopter properly. So this is how we are designing help us to understand the real Sikorsky failed helicopter. As a designing engineers, we are as aerospace engineers, we have solved this problem using designing framework. Thank you all.
Thank you, sir.